Hi everyone, this is Sean Ismail from Cloud Ranger and you're viewing the Microsoft Azure training. Today is the part 9 of Azure Virtual Machines and we're going to talk about VM storage. Now, before we start this, I know we have come a long way. This is part 9 of virtual machines because there was just a whole lot to cover, and these are stuff you are going to do on a daily basis in your production. So I did spend quite a bit of time on these virtual machines. Having said that, I did mention before that we are going to have separate, sessions on VM storage. On storage in general. But what I want to do in this session is actually, talk about some storage stuff that we have just been ignoring for now and that are directly related to virtual machines. So this is not going to be a session on storage accounts and storage in general, but some storage stuff on virtual machines. And I'm going to try to keep this as brief as possible. So let's get started. So the first topic today is VM disk caching. So what happens on premise is that you have your resources always close to each other. So you'd have a server that's probably connected to your SAN or NAS or direct attached storage, whatever, but they're going to be very close proximity with each other. So for example, you're not going to have a server sitting somewhere in your data center or in your office and then have the storage or the SAN totally on a WAN link miles away. You wouldn't do that. But in Azure or in cloud, there are chances that there are certain, you don't have to go like thousands of miles apart, but there are chances that the resources are not going to be together all in the same rack or in the same cabinet or even in the same data center facility. It would still be in the same location, like for example, East US or West US, but they might not be very close to each other. So what Microsoft did is like when you're creating a virtual machine, it has given some options for disk caching. So it basically says that there's going to be some read and write buffer, and this read and write buffer is going to be for both the operating system disk and data disk. Like you know, in Azure, operating system disk and data disk, they're very well distinct from each other, right? And this cache itself is actually located on the physical disk on the host server. So if your virtual machine is created on a physical server, there is going to be some disks in there where, as you know, the temporary drive is there from our previous sessions. Like every virtual machine has a temporary drive that's sitting on a physical disk on the host server. So this cache is actually in the same location on the server. It's on a physical disk. Okay. Now, I've got some conflicted documentation on this, but OS disk cache settings can only be set using PowerShell, a data disk from Management Portal and PowerShell. But it seems like in the Management Portal, I do see a setting for OS disk caching from the portal itself and not only from PowerShell, okay? I'll show that to you momentarily. And the other thing I want to talk about is that this caching can be created or modified while the virtual machine is being created or after the virtual machine has been created. This is similar to a lot of other things we have done, in both scenarios, while the virtual machine is creating or later. And the default cache setting is read and write. So by default, the cache setting would be read and write for both OS disk and data disk. Now, frankly, I have never had to change the cache settings for OS disk or data disk. They are read and write, they're set for efficiency, and whatever the case is, right? Unless you have any very compelling reason that you want to do that for the OS disk, do it. But otherwise, leave it alone because that's probably the best setting that Azure has for you by default. Now, with your data disk, the default cache, there might be certain scenarios where you want to make it only read only or no caching whatsoever. Um, and you know what, when you make domain controllers and go through the Azure best practices to make domain controllers, you'll see that this cache setting plays a big role in how your domain controller will be installed. Um, you know, for example, I do not want to get into too much details, but for example, when you create a domain controller, they say that your Active Directory in data for sysvol, NTDS, and all that should not be on your C drive. It should actually be on a data disk, which is completely different from how you might have made domain controllers all your life, really. In Azure, they want the data disk to have your Active Directory database is located in there. And this is the best practice for, and not only best practice, is the safest way to have a domain controller in Azure. And the reason behind that is exactly because of this cache setting. The domain controllers are not too friendly with the cache that Azure has, so you probably want to keep this on a data drive where the host caching is set to none. So there's no host caching whatsoever. So Active Directory stays sane. But there are situations where you'll do that. But nevertheless, I've never seen a scenario where I had to go and change the OS disk caching, however. For data, sure, for domain controllers, this and that, but for OS disk, never. So leave it alone if you have to, unless you have a very specific configuration where you want to go and change something for your operating system disk. Okay? So moving on, I do have two PowerShell commandlets here, one for the OS disk cache and one for the data disk cache. So the first thing we do, for example, here is we get hold of the VM object, CRanger VM1001. That's the virtual machine name and the service name. And after we have got the VM object, this is the commandlet you use, and we have not used this commandlet before, set as your OS disk. So set as your OS disk with the switch host caching read-only would actually go and make the disk read-only caching. If you do not go and do this, by default, it's read and write. Okay. With your data disk, however, we have used this commandlet before, set as your data disk for creating data disks or making modifications to it. But this time it's the same switch, host caching, and we are going to make it read-write for the Azure data disk. So they are pretty simple commandlets here, okay? So let's go through a quick demo. I want to show you how this is done in the management portal. So this is what I was mentioning. So if you come to your virtual machine here, CRanger 001, by the way, I have these two virtual machines already created, basic virtual machines really. Default settings anyways. So if I go to disks here, I can see that CRanger 001 is attached. This disk is attached to CRanger 001. So I know this is the operating system disk, okay? So I do have this edit cache option here where the disk can be made to read only or read write. By default, it's read write, like I mentioned, for the host caching for preference. So this the documentation where it says that you can only change this setting for OS disk from PowerShell is not really accurate any longer. You can actually do this from Management Console. Okay. And if you wanted to have a data disk, so for example, you attach an empty disk to this one, so far we had always just put, for example, 5 gigs here, and we have moved on. But as you can see, host cache preference by default has no setting for caching, but you could change it to read only and read write. Okay. Before, the documentation at one point was that this was read write as well, but you leave this one as none. And this is what I use, but I go with the default settings all the time. And this is the setting you probably want for when you're creating a domain controller as well. You do not want host caching preference on the data disk. Okay, so that's all that really there is to it with host caching. And now let's move on to the next topic. Back onto our slides, we are going to start talking about disk redundancy, and we're going to talk about both durability and performance. Now, this is something we are going to talk in details in storage accounts when we go through the storage sessions. But I'm going to briefly touch this and just go through this so you understand where your virtual machine disks are located if you actually are just here to watch this video and you're not following through the entire series of these trainings that are already there are going to happen. So there are 3 tiers. I mean, I wouldn't call it 4 tiers, but there are 3 tiers for 3 good reasons, okay? So this is your storage account, and your disk is created in the storage account. So when you create your storage account, you are given that option that how do you want your disks to be. So the first one is local redundant tier. This is the default one, okay? So by default, what it's saying is that each disk is replicated 3 times in a given data center or facility. What it means is that in your on-premise systems, when you buy a server, you'll have RAIDs, right? You will have your disk geometry, you'll have probably meters, you'll have RAID 0, RAID 1, RAID 5, meter RAID, whatever. And what do you do is that basically you're trying to, prevent disk failures. That's why you have a durability of those disks. And for your operating system, for example, you'd have RAID 1, meter, or whatever. Now, with Azure, we have not done that so far. And this is no different from your on-premise virtual machines. When you go to create your virtual machines, you just give it some storage. Now, underlying SAN or local disk, you don't go and set the geometry of that on the virtual machine. And it's similar. So in Azure, we do not do RAIDs, but what Azure does for you in the back end is that when you have local redundant tier, it will have your data or each disk replicated 3 times in a given data center. Okay, so if one of the disks fail or whatever happens, you still have the data in that same data center in 2 other locations. So that will ensure that breaking a disk is not going to be an issue. But then there might be some issues that you might say that, okay, I don't want my data to be in the same location or in the same data center. That's why we have the zoned redundant tier. So here, each disk is replicated 3 times across 2 or more data centers. However, they're in the same zone. And the word zone, I want you to get used to this terminology because we call it location or we call it region. But when it comes to storage, they call it zone. But essentially, it's the same thing. So what, like I mentioned in my previous sessions, that a single location might have multiple data centers or facilities where you have your resources. So you could have East US2, which might have 5 data centers. They are in 5 separate data centers, but they're still located in the same region, same location, or same zone. That's what we call it. Those terms are synonymous here. So what Microsoft will say that, okay, if something happens to this data center, if you go through a zone redundant tier, I'll make sure that a copy of your data is actually there in another data center in the same region. So you'll still be in East US2, but you'll have three locations or 3 or more. Not 3 and more. 2 or more data centers will have your this data. Okay, so which is pretty good. Now, the next one is geo-redundant tier, and chances are this is what you might use in your production most of the times, because this happens to be the most safest, and I'll explain in a bit why. Each disk is replicated 3 times in the primary zone as well as 3 at a remote zone. So for example, we go create a virtual machine in a storage account with geo-redundant tier, means we'll not only have the 3 copies of that disk in East US2, but it will randomly pick another location, for example, West US or I don't know, Central US or North US, whatever, another completely different region or location, and store 3 more copies with that. So take a guess, what did this just address? Some of you might have got this right away, people who are really veterans and who have worked on systems for a long time. This actually basically takes care of your disaster recovery, or this takes care of your DR scenario. What happens if California goes underwater? Where does my data go? So that's where your data goes when you do geo-redundant, is that you might be in West US and you might have your primary data there, but chances are when you are in geo-redundant here, the East US probably has 3 copies of that data as well. So this takes care of DR. So in production, this might be something you want to do. Now, the next one is not exactly a tier, but it's a geo-redundant read access, means that your data is read-only in the secondary zone. So your primary zone will have read-write, but your secondary one will only be read-only. So again, in DR scenario, you might want a situation where the data that's located in the DR site or the secondary site in Azure terms or secondary zone, you want that to be only read-only. So if there isn't damage done to the data, write damage done to a data on your primary zone, the secondary zone will be read access only, so the damage over there will not be done. Now, I'm not going to get into details on how these are configured a lot, because we are going to have a session dedicated to all of that. Okay, so but I do want to show you something really, really quick. So if you go to storage account, new storage account, and quick create, as you can see, when we create a storage account here, let's call it C Ranger software or something weird like that. And let's call it East US2. This is going to be my location. it gives you the replication option that do you want the locally redundant, geo-redundant, zone redundant. So these are all your tiers. Remember, these are the ones we have talked about. And this is how you set up the storage account. So anything that's created in this storage account will being um, end up being based on the tier, the data will be located. So I'm going to just keep this locally redundant, and I'm going to click OK. And you can do similar thing with PowerShell, but I'm not going to go over all of that right now. Okay. So the next thing I want to talk about is disk redundancy from a performance point of view. And this is entirely based on IOPS and disk IOPS. So we have not talked about this before, but I did show you that site before, I am quite sure. This is the URL. Please pause the video and make sure you have it. These are the things you should actually bookmark because you will be referencing them quite a bit, and this data does change quite a bit. Well, if with more previews coming to general releases, you'll see this data change quite a bit. Like, for example, this was updated March 27th, which is quite recent, 2015, at least when this video is being recorded, okay? So here you can actually see there was something I did go touch before, is the IOPS, okay? The max IOPS and the amount of data disks. So this might be a document that's familiar to you guys. So what I want to show you is that every single disk has an IOPS of 500 per disk, okay? Input output per second, 500. So that's standard across Microsoft Azure, that every disk will have 500. Now, you could have, two disks over here, like data disks, for example, it will be 2 into 500. Okay, so that means it's not saying that it's going to be 1000. It's just that each disk will have 500. So you might get a total of 1000 IOPS. Not from single disk, but both the disks. This is actually both the disks. We have a lot of confusion with that, where people will come and tell me, oh, so I have this large VM, which is A3, and it seems like, there are 8 data disks I can attach to it, good for me, and I have 8 multiplied by 500, so what is it? Like, am I getting 4000 IOPS from one disk? No, you are not. You are getting still 500 per disk. It's just how it's represented here. However, I'll show you how to get more apps in a bit. Now, as you go down, you'll find out that there are other very extensive series of data disks with DS series and D series where you have, these are only 2 disks you can put them, but you can have 3200 IOPS from each disk, and then this can go, it can get quite crazy with the DS series. It's new series of virtual machines that just came out with. Okay, so I'm going to show you a nice trick to see what's going on and how to increase your IOPS. Okay, so it seems like we do have a little bit of time. I know this is going a little bit out of scope, but this is something you'll be doing in production. So give me a moment here. Okay, so I do have everything ready here. So like you noticed that I had 2 virtual machines created. So I'm going to go to CRanger001. And I am on the virtual machine. Oh, by the way, Microsoft just released the image for server 2016. So I'm right now on a 2016 server. You could be very well on a 2012 R2 data center. It does not matter what server you're on, but this is actually a 2016 server. Um, anyways, it's an evaluation copy. It's a technical preview. It's not released to the public, but you can use this from Azure. Okay, so I'm just using that over there. So this is the link. You want to go and download a tool called SQL IO. So this is what you are going to download, and you install this SQL IO tool. It's a very small tool, does very basic things. So once you have installed that, you go to your console or PowerShell, whatever, and this is the location you want to go to, Program Files x86 SQL IO. Okay, and in here, you'll actually see the tool SQLIO.exe. Okay, so that's the tool we want to use. Anyway, so what we are going to do is we're going to run this tool to actually run some sort of a stress test on the disk itself and to see that how it performs IOPS wise, okay, input outputs per second. And what we're going to do is there are a bunch of switches here. The K option specifies that it's going to be a read-write. So we are going to do both read and write on that disk. Dash S means we are going to run the test for 60 seconds. 60 seconds might be too much, so let's make it 30 seconds for us. Um, um, dash O8 here, O indicates the number of IOs that can be outstanding in a single thread. So it actually creates multiple threads to actually run these tests. And B option is actually the IO block size in kilobytes, right? So, you know, 8 would be about 64 kilobytes of the block size, input output block size, okay? And what we're going to do is we are going to test file. We're going to run first a test on the C drive. So this is the operating system drive that we're going to run this on. Okay, so let's go ahead and run this test. And what we are expecting is, well, let's first actually get there before we talk about what we are expecting. -A-B8, and we are going to do this on C drive. So test file.dat. Okay, in case any of you are wondering why this, all of a sudden PowerShell is showing these colors. Seems like it's a new feature that's going to be on Server 2016. So SQL IO cannot be found. Okay, so let's see what happened here. I am pretty sure it's there. SQL IO. I think I might know what happened. Let's see. So that may be the reason. It's the full path. -O8, -B8, C test file.dat. This is something that might be used as a proof of concept, or this might be something that can be used in a production to actually run a test and see what kind of IOPS you get. There are applications which are very particular about the disk IOPS, so you have to remember that. So anyways, this test is going to run for few seconds, I think 30 seconds in total, and it's going to come and give us the results. So I'm going to pause this video and come back when the results are up. Okay, so I've ran the test a few times. I actually missed the -S30 switch over here, but as you can see, it came back with the IOPS. It ran for 30 seconds by default anyways. It came back with 23,582 IOPS. I ran it the second time, and it's pretty close. So it's almost easy to deduce from here is that it's on your C drive, you are getting up to 24,000 IOPS per second, okay? So what we have to do is, and this was on the C drive, this was the primary disk drive, okay? What we are going to do is we are going to attach a data disk, an empty data disk to this one, okay? And VH disk, we are going to call one data here. And this is going to be like 5. I'm not going to have any caching done here. Let's add that disk here. Okay, that took a few seconds to create. So we do have a data disk now that's attached to C Ranger 001. Okay, this one doesn't have the operating system, so this one is the disk. So let's come over here. We will need to initialize that disk. So let's go to disk management. By default, let's see. Okay, so it's showing up here. This is the 5 gigs disk we have attached, so we can see that. Okay, so let's go ahead and create a new simple volume on this one. 5 gigs. Let's call it F drive. Keep everything normal the way it is. Click on finish. Should be up and running momentarily. Cancel. I don't want to format the disk. It's formatting already. It's a very small disk. Should be done. Okay, so it's up and running. So let's go over here, and you can see there's an F drive that's created. It's nice and empty. Okay, so we're going to run the test on this one. So let's go ahead, clear this screen here. So we're going to run the same command, but this time we're going to do this on the F drive because this is the data disk we have attached. Okay. So Probably shouldn't have cleared the screen, but okay, let's run this test. So this test is now going to go to F drive, and it's actually going to create a data disk. As you see, it created the data disk and it's doing its thing. So I'm going to come back after 30 seconds. Okay, 30 seconds over. Now you can look at the data that came back here, and you can see it's 503.33. So it's only 500 IOPS per second when you attach a single data disk. This actually corresponds to our standard tiers where you can see that one data disk will go up to 500. Okay, so you could get a maximum of 500 IOPS from a single data disk, and this is actually a proof of that live on how to check that 503, which is close to 500. So what happens if you actually want a data disk to actually go more than 500 IOPS? Just like, for example, we did our C drive. Well, the C drive is already created for us, so you do not know better. It had like something insane, like 24,000, I believe, IOPS. So how do you get your IOPS more than 500? By design, it's 500 for a single disk. So some of you guys who actually do a lot of server stuff, server admin stuff, the answer to that is you take multiple disks and create a RAID. Okay, so you will have like a RAID 5, for example, you'll have a higher IOPS from there because you are reading and writing at a much faster speed than you would ideally have a single speed with a single spindle. Right? This is how data is distributed on RAID. So I'm not going to get into the geometry of how RAIDs are, but if you have actually 5 disks kind of created in a pool of disks and you represent that as a data disk, you would do that. So the way you do that in Azure, and you might actually have to do that for certain applications. So for example, think about SQL. The more IOPS you have, the faster your data is going to be accessed. So chances are you do not want one data disk with just 500 IOPS. You probably want 5,000 or even more, like 50,000 on your IOPS. But how do you do that in Azure? We cannot obviously do RAID here. Well, the way you do that is by creating something that's part of Server 2012, and it is called, well, it was there since 2012. It's called Azure, storage spaces or disk spaces. And I'm going to show you how to do that with 3 disks here. This is not a 2012 server. It's a 2016 server in preview. So I'm going to try doing that, and this will be a nice experiment. Okay, so let's actually delete this volume. We do not want this volume to be anything to be done with this. I'm going to actually, in fact, just make this offline at this point. Okay, so we have 2 disks. I mean, we just have 1 data disk. I'm going to attach 2 more data disks to CRanger 001. Okay, so it's going to be similar. I'm going to just call this. Wow, what did I call this guy? Interesting. Let's go to the storage. Let's try to find out what I might have called it. Not this one. That's why you should actually name it appropriately. Anyways, so I called it 1 data VHD. So this one I'll call 2 data VHD, okay? Just to keep some consistency over here, 2 data. So it will still be 5 gigs. You need them to be all of same size. So let me create the other one as well. And once all 3 are created, I'll come back. Okay, so all disks were created. Let's dismiss this. So let's go back to CRanger 001. Okay, come over here. You should see 555. So we attached 3 data disks and it's all here. Okay, so what we want to do is let's go to the server manager. In server manager by default, since server 2012, I'm on server 2016, but you'll find similar, it's same steps. You'll come over here and some of you might already know this. These are all the disks that you have on this operating system. I basically want to go to storage pools and I'll see primordial here. And these are all the 3 disks that are available to me. So these are the 3 data disks I attached from Azure. I'm going to press on Shift, go over here, oops, and select all of these disks. They have to be all of the same capacity here. Right click on that and go New Storage Pool. So I'm going to create a storage pool from these 3 data disks. Click on Next, storage pool name, data pool, whatever you want to name it. It's saying that how much do you want allocation, everything. I'm going to keep it default. Create. So it's creating the storage pool for me. Take a couple of seconds. And it's completed. Click on close. As you can see, there's a pool now called data pool. The primordial is gone, and these are the 3 disks that are all part of the pool. Okay, so the total capacity now became, well, it's not going to be 15, it's 555 each. It's 12.8, so that's the total with the overhead. So come over here on the disks, and this is the C drive, by the way. So if you go to this one, well, there is a D drive, so I guess we have to create a new volume here. So create a new volume, next, rescan. Hang on a second. You know what? I did not create a virtual disk. Hang on. So now that the storage pool is created here, I do need to create a virtual disk. So let's go ahead and do that first. So we'll come back to storage pools here and go to new virtual disk. Actually, hang on a second. So this is where we created the pool, right? This is where the primordial was. I went and selected all 3, created the storage pool. Now the storage pool showed up. Now under virtual disks here, we want to create the virtual disk. It's asking which pool do you want. This is the pool I want. Name the virtual disk name. We'll just call it data. Storage layout. We'll just do it parity. There's the 3 options you have, simple, better, and parity. I'll do a parity over here. Or you know what? I could do data type section. Let's keep it simple. I am going to keep this as fixed size. Specify the size. Let's take it maximum size. That comes out of all 3 disks. Confirmation. Create. So let it create the virtual disk. Okay. Now it does give you an option right after that. Do you want to create a volume? So we do not have to jump to that volume page. So I say, okay, let's create a volume right after. So server and disk. This is the disk we have. The size is 12, so it has some overhead. We'll call it F drive again. Let's keep everything the same. Confirmation, create. Took about 10 seconds. And now, technically, we should have F drive. Okay, so we had 3 disks, 5 gigs each, and we have taken them and created a storage pool using the built-in features with Server 2012 onwards. And we created a storage space, and we named it, we created a virtual disk and created a volume out of that virtual disk, and we call it F drive. Okay, so this is no longer just a regular data disk. It's 3 data disks combined together, and it's a simple volume. Now, I want to run the same test on this. This is from our previous one where it was 500 IOPS, and I'm going to run the same test on this. This time I know this F drive is not a regular single data disk. Okay, so let's go ahead and run the test. I'll come back after 30 seconds with the results. Okay, so the results are back. Look at this. The IOPS actually jumped to 1000 from the previous where it was 500. So when it was a single data disk that we connected to the virtual machine by itself, it could not give us more than 500 IOPS. But with 3 combined to one single storage space or one single endpoint of storage, it actually increased the IOPS. So you could add more disks to this and increase the number of spindles, and technically, increase your IOPS to like some enormous capability where if you have some serious data that SQL Server needs to do. So this is something you will be doing with your virtual machines in production in certain scenarios like SQL Exchange and stuff like that, okay? And do remember that Azure now has premium storage, and with premium storage, rather than the 500 IOPS, you can actually get a lot more IOPS. So if you're building a SQL server, you can use premium storage and you can have the DS sized virtual machine connect to each other and have a very nice hunky-dory high capability SQL server. But this is more of increasing the efficiency or IOPS of a single VM attaching 3 data disks and creating a storage space and doing all of that funky stuff to increase your IOPS, to increase performance. So this goes back to our disk redundancy and performance aspect of Azure Virtual Machine. I know this went a little bit out of topic, but this is what I am trying to provide a value of hands-on production level, uh, you know, insights to what you need to do in real life to do something like this. SQL, there are more tools out there from Microsoft. I like SQL IO because it's very basic. This tool helps me get the IOPS really quick. And this is good for proof of concepts if you're demonstrating something to your client internally or externally. So that's all there is to disk redundancy. The next thing I want to talk about is Azure Files. This is a preview feature in 2015 right now, at least at the time when I'm recording this. It's a preview feature, means chances are this is not part or activated on your subscription. The only way you can actually play with this and activate on your subscription is if you go through your Azure contact support, create a ticket. It's very easy actually. The way you do that is you come over here. Let's go here, Cloud Ranger Ball. You see contact Microsoft support. Okay, you click on that and it creates a ticket. I mean, it gives you a little form where you can create a ticket. It gives you a little place where you put the description of the ticket. If you're running an Azure trial, in fact, pay as you go. I do not have any technical support, so make sure you choose the billing support. Okay, part of billing support is enabling preview features on your subscription. By default, it's not a subscription that is given to you. That includes premium storage as well. Premium storage and Azure Files, these are not released to general audience yet, so you might have to, to enable it on your subscription, open a ticket and do that. Could take up to a day or two for that to happen. So, pause the video here, come back later, go ahead and create the ticket for Azure Files for, if you want to do this hands-on and practice. So what does Azure Files do? Azure Files is basically an SMB endpoint from an Azure storage account. So that's the technical mumbo jumbo, right? What it is in basic terms is that it lets your Azure storage account act or kind of portray itself as a file share. You might see the benefits of this in Azure like right away. Like, where do you store the files in your, in your on-premise today? It's probably a file share. It's probably a file share on your SAN if you have the SMB support, or your NAS, or a file share server. Well, you could do the same over here with a virtual machine, create a data disk, and put all the ISO files on there, for example, or your data disk, like installation files for SQL, SharePoint, Exchange, whatever. Or you can use something like Azure Files. What Azure Files will do is it basically gives you an endpoint which you can access through file share. Okay, so I'm going to demonstrate this like in record speed, and I'm going to show you how this can be done. So let's go over here. We already have two virtual machines, CRanger 001 and 002. And I am going to create a storage here. You know what? I'm going to create a totally different storage account for this. I'm going to call this actually, I did create something before. Yeah, I have a Ranger software storage here, right? So let's go in here. Let's go to the containers. There's no container. There's nothing going on. It just is. I think I just created this to show you the geo redundancy and all that redundancy. Okay, but it's a basic storage account where nothing else is going on. Okay, so it's called CRanger software. So I do have a little script here. So the name of the storage account is CRanger software. So the storage account is CRanger software. You need the storage account key. Okay, so let's not get into too much details on what these keys are, but for this example, let's go to manage keys, and I'm going to take the primary key. So click on this button, it actually copies it. So it's a very nice, handy, nifty feature. So this is a special character key that's only going to be known to you. It's very unique. It almost acts as a password. And I'm going to create a shared folder called, I don't know, my software, maybe. Okay. Next, I'm going to create an Azure storage context, which will take two parameters. One is the storage account and the storage key. So this is storage account, this key goes to the new storage context. So I'm going to store that in here. And with the new storage context, what I'm going to do is I'm going to create a new storage share, Azure storage share. This is the commandlet that I want to show actually for the Azure files. This is basically going and saying that create my software share on this storage context means in this storage account. So let's not get into too much details on this. This is the part I want you to concentrate. That basically new Azure storage share, it creates the file share. Okay, so let's go ahead and run that. That's it. It actually went and created that. There is no way for you to view that from here. If you now go over here, like for example, was to see the containers and stuff over here, it does not show this over here. The only place, unfortunately, you can see that is in the preview portal. So the way you go to the preview portal is the Azure preview portal here. I know we are not working on the preview portal much. I'm keeping us in the management portal, but preview portal is going to be Microsoft's pretty much de facto the new portal. So someday they're going to completely, get rid of this portal, and this is where it will be. You have a lot more capabilities on this portal, but on your exam there will be both. So I'm concentrating more on the management, but feel free to come over here and explore. You can do the same things you do over here. It's just that it's separately or differently organized, and you will see that there are certain things that are available here that's not there on management portal, and there are still stuff that's on management portal. They did not bring it over here. Okay, so let's go over here. I want to go to browse. In browse, I think I need to close that, go to browse. These are stuff I had done before. I'm going to go to scroll down to storage accounts. The storage account I want to go to is C Ranger software. Once I'm at C Ranger software, I can actually see file shares. Okay, so let's click on file shares. And you can see it actually created a file share named my software. This is the stuff that we created. Okay, so the URL to that is pretty much C Ranger software, which is pretty much our usual one. If you remember from before, when we go over here, and we have looked into some of this when we were creating the image, we were working on the blob.core to store our image and all that. But with this one, if you see right now, it's actually file.core. So this is the Azure files. Okay, so let's copy that because I will be requiring this information uh, over here. So let's comment and paste this over here. The part that I'll actually need is this part, CRange software. Okay, so the share is actually created. What I'm trying to demonstrate right now is that how do you get to that share? So we have one of our virtual machines here, CRanger 001, that we were working with. Let's go ahead and map that, right? So if I come over here and I go to computer, map a network drive. So I'm going to call this, for example, software. So I'll just call it S. Over here, this is what we need. We need this guy. So I'm going to put //, and I need a backslash over here. So converting this to UNC. Okay, this is no different from how you do this on premise. //, this is how you connect to a file share server with UNC. So this is what you put for the folder. Okay. Do you want to reconnect at sign? Sure, whatever. You need to connect using different credentials, right? Because you'll need different credentials. So what's going to be the username and password? If this was domain, you do your ACLs or ACLs and you do that. Here, your account name is going to be your storage account name, C Ranger software. So let's go ahead and do that, C Ranger software. And your password is going to be this long key that we had got from your storage account. This is very unique to that storage account. So this becomes technically your password. I'm going to remember my credentials, click OK, and let's see if we can connect. Well, we just did. So you come to this PC, and you see that there is something called as, well, it's not showing what is called here. Let's see if I can list this and make this better. It's an S drive, okay? So this is the S drive we created. You go in there, and this is pretty much your shared folder. So let's create something over here. You can put anything over here. This is how you can upload information. I'm going to create a test document here. I'm going to put this, for example, SQL IO tool in here. I'm going to do this. This is where you could probably put your other ISO files for SQL, for your SharePoint. So you have a single location with your software repo. So let's go access that from cRanger 002. So this is a completely different, VM we haven't worked with yet. Map a network drive, map a network drive. I'm going to do a similar thing over here as well. I'm just basically going through this double process to show you that, this is nothing but a file share that everybody can access. Well, people you give access to through this username and password can have access to. Okay. And it's something new. That's why it's still in preview. It's something new that Microsoft is doing, and chances are information might be on your exams. And this is a very handy thing in production. So I'm already using it in production for at least storing all my ISO files and stuff like that. So put this information here. Remember my credentials, okay, and voila, this is where we are. So we are on cRanger 002 server, as you can see, and this is the information we have right here. And cRanger 001, you can see it's also information we have on these both servers. So it's basically nothing but a shared folder that we can access from all the virtual machines. It's a perfect tool to store stuff rather than spinning up an entire virtual machine to do that. Okay, so basically it's a file share on Azure on a single storage account. And that's what it is. There are a bunch of PowerShell stuff that you can do on that. I don't want to get into details on this right now, but there are stuff you can do there. So I think that pretty much wraps up today's session. It's not really a super long one, but there's a lot of hands-on value that you can get out of this session, stuff that you will be doing in production most likely. So we'll be doing a lot more in storage sessions, but this is something that's very, very related to your virtual machines. So I went a little bit ahead. A little bit more, to do the SQL IO test. Those are definitely not going to be there for your exams, but that stress test or that little performance test that we did over there is something you'll be doing in production. And that's my goal, to give you some value out of these videos, even in your production as well. Okay, so as usual, my training site is at cloudranger.net/Azure training. YouTube channel is at Cloud Ranger Network. Follow me on Twitter at Cloud Ranger blog, and you can always email me, Sean@cloudranger.net. And I will be seeing you in your next session. We have one more small session for virtual machines, and I promise that that'll be the last on virtual machines. And we're going to talk about virtual machine monitoring. It's not going to be a very long session. It's going to be a short session, nice and sweet, to give you and wrap up the exam point of view on most virtual machine stuff, and then we'll go to the next sessions. Okay, so thank you for viewing, and I am going to see you in the next session.